Welcome to a video on graphing the quadric surface, the ellipsoid. As discussed in the introductory video, a quadric surface is given by a degree 2 equation in the following form. However, we're not going to be considering the rotation of these quadric surfaces, so our equations will not contain an xy term, xz term, or yz term. In this video, we'll focus only on how to graph an ellipsoid. The degree and sign of the degree 2 terms, as well as the terms that are present, help us determine which of the 6 quadric surfaces is given. Now, to graph a quadric surface, it's often helpful to graph the xy, xz, and yz traces, which is where the surface will intersect each of these 3 planes. And sometimes there may not be a trace in the given plane, but if we make a trace that's parallel to the given plane, there usually will be. Now, to determine the xy trace, we're going to set z equal to 0. To determine the xz trace, we'll set y equal to 0. And to determine the yz trace, we'll set x equal to 0. So here's the form for an ellipsoid. Notice all 3 squared terms are present. They're all positive when the equation is equal to 1. So we're going to go ahead and take a look at an example where we determine each of the 3 traces. So if we want to determine the xy trace, we're going to set z equal to 0, which will give us the equation x squared over 16 plus y squared over 25 is equal to 1. And we know from our study of conic sections this is an ellipse centered at the origin, or the point 0, 0. The major axis will be the vertical axis, and since our denominator is 25, we can go up 5 units and down 5 units to determine the endpoints of the major axis. So this is scaled by 2's. So this would be positive 5. This would be negative 5. So those will be the endpoints of the major axis. And the minor axis will be 4 units to the left and 4 units to the right of the origin. So here's 4 and here's negative 4. These are the endpoints of the minor axis. So the xy trace would be the ellipse passing through these 4 points, looking something like this. Next, to determine the xz trace, we'll set y, the missing variable, equal to 0. So that'll give us x squared over 16 plus z squared over 4 equals 1. So now we're going to call this the x-axis, this the z-axis, and we have another ellipse. Now the major axis will be horizontal with a length of 8. So from the origin, we'll go 4 units to the right, 4 units to the left. Again, this is scaled by 2's. And the vertical axis, now the z-axis, will be our minor axis. Since here we'd have c squared equals 4 and c equal to 2, we'll go up 2 units and down 2 units on the z-axis. This will give us where the ellipsoid intersects the xz plane. Again, another ellipse, but a different shaped ellipse. And then lastly, to determine the yz trace, we'll set x equal to 0. So we'd have y squared over 25 plus z squared over 4 equals 1. Notice now we're calling the horizontal axis y and the vertical axis z. So b squared is 25, so b is equal to 5, so we'll go 5 units to the right and 5 units to the left for the major axis, and we'll go up and down 2 units again for the minor axis. These are the endpoints of the major and minor axis. So the ellipsoid intersects the yz plane in this shaped ellipse. Now at this point we could try to graph it by hand, but graphing software is so readily available these days, we're going to go ahead and graph this quadric surface using Maple. It would look something like this. And again, if we take a look at where this surface intersects the 3 planes, it would look just like what we had here as our 3 traces. If we take a look at this in a more dynamic graph, it'll become much more obvious. Here's the graph of our ellipsoid in space. If we take a look at the xy trace, or view this looking down on the xy plane, here you can see the xy trace. Now if we take a look at this from the view of the xz plane, as we see here, we can see our xz trace, the ellipse here,